Hi, I'm Amir Hossein Mirza Bozorg, and in this video I'm gonna talk about Comprehensive Abaqus Package Chapter 12 using Abaqus documentation. How to ask your video related questions. Don't hesitate to ask any questions you might have about the explanations presented in this video using the comments below. We will try to answer all questions regarding the video details in the comments below. New Abaqus users who want to develop their modeling skills faster in their projects can request user-oriented online and offline services. Subsequently, we offer a step-by-step guidance, tutoring, and consultancy regarding their problems. The online service includes online sessions, and the offline service includes creating special tutorials. In addition, a combination of the two can be requested. This is the table of content for Chapter 12. Okay, now I want to start chapter 12. Chapter 12 is about using Abaqus documentation. Abaqus has a good and valuable documentation, and it's very important to use it correctly. And there are a lot of information in the Abaqus documentation. But for example, in some other softwares, I don't want to name any software, but in most of the engineering softwares, they don't have good documentation. But Abaqus has a good documentation like MATLAB. Also, MATLAB has a very good documentation. And also Abaqus has a good documentation. Here I want to talk about Abaqus documentation. In my system, I have installed Abaqus documentation for version 6.14. Okay, I open it. This is the Abaqus documentation for version 6.14. Also, it is available in the internet. If I search it in a new tab, I go to the google.com and I search Abaqus online documentation. Okay, Abaqus online documentation. And here you can see Abaqus 6.14 documentation. And they are similar. But in the web version, you cannot search. But if you install it, you can search easily. For example, I go to Abaqus Analysis User's Guide and I search, for example, XFEM. And you can see that it guides me. But here, if I search XFEM, it says not found. So you cannot search in the web version. And this search is very good. And also here I'm gonna talk about all of these parts. Okay, all of these parts. First, Abaqus CAE User's Guide. Also, let me show you the Abaqus documentation for version 2022. It is not in the web, it is in the Abaqus website. It is in the Abaqus website here. This is 3ds.com. This is 3ds.com. You must create an account in this site, and then you have Abaqus example problems guide. This guide contains detailed examples designed to illustrate the approaches and decisions needed to perform meaningful linear and nonlinear analysis. Many of the examples are work with several different element types, mesh densities, and other variations. Typical cases are large motion of an elastic plastic pipe hitting a rigid wall, inelastic buckling collapse of a thin-walled elbow, explosive loading of an elastic viscoplastic thin ring, consolidation under a footing, buckling of a composite shell with a hole, and deep drying of a metal sheet. These are very famous examples. I have worked on deep drying of a metal sheet and also a composite shell with a hole. It is generally useful to look for relevant examples in this guide and to review them when embarking on a new class of problems. For example, here we have Abaqus example problems guide, and you can see that we have a lot of sections: static stress displacement analysis, dynamic stress displacement analysis, tire and vehicle analyzers, mechanism analyzers, and others. For example, here I go to dynamic stress analyzers and rigid projectile impacting eroding plate. I want to work on this example here. Here it says product Abaqus explicit. It means that this example is modeled using Abaqus explicit solver, and they didn't try Abaqus standard. Maybe it is not possible to do it with Abaqus standard, and in this case that's correct. You cannot do this analysis using Abaqus standard due to the convergence issues. I will talk about it in chapter 11. And here you can see the explanations. There are some explanations, and here we have input files and also the results. As you can see here, we don't have any CAE file. Here we don't have any CAE file or JNL file. They only provide IMP file. And for example, you have not installed the documentation. Okay, you have not installed the documentation, and you have access only to the web version. I go to the Abaqus example problems guide, and here we have rigid projectile impacting eroding plate, and I want to use these IMP files. In some of the examples, this is not enough to only use this IMP file. But if you do like me, you will not face error at all. And also, they don't share the CAE files because they are very valuable. All of the efforts that you have done are in the CAE file, so it is very, very valuable. If you search in the Google or in the LinkedIn, most of the people, they don't share their CAE files because they are very valuable. They only share IMP files, okay? Because they cannot be imported correctly. A CAE file is changed to an IMP file correctly, always correctly. But it will not be done in the reverse direction always correctly. Yes, what is your question? Please ask your question.
So you said that we must import the INP file from the job module?
No. We don't import it. We are running it. We are here. I import it also. Okay. I will also import it. But if you import it, most of the time it doesn't work. If you want it to work, around the disk they have used infinite elements. In chapter 13, I will talk about infinite elements, and here there is no need to talk about it. And here you can see that it's if I set it to XZ, it is an oblique impact. Okay, it is an oblique impact. And this is also the PQ contour, and here you can see it. When you import infinite elements, its shape will be like this. Here you cannot see the borders. Okay, this is natural. And also when you import an IMP file, you will face the orphan mesh. This is orphan mesh. Orphan means someone who doesn't have father. And here I want to mention I really like to mention some political examples, but I can't. Because I like my life too much. And yes, it's this is orphan mesh. And what does it mean? It means that this part doesn't contain any geometry. Okay, this part doesn't contain any geometry. So it is only created from node and element, no geometry. In all of the examples which I have solved for you, first I create a geometry in the part module, or even we can import it from SolidWorks or CATIA or Siemens NX or Inventor or others CAD softwares with standard formats like STEP and Parasolid, or even CAD part for CATIA. But here it doesn't contain any geometry. It is orphan mesh. And as you can see, it is a special kind of green. And for example, in the property module, you can see the definition of the material. They have used shear failure model in the RHA. No, they have not. I don't know why they have written that. They have defined ductile damage with damage evolution displacement at failure is 0. It means that they have defined instantaneous damage. I will talk about it in chapter 11. And also this is the plasticity definition, elasticity definition, and density definition. They have used meter as the unit of length. And also this is the step settings, output settings. Okay, so if you have any question, please ask. If you don't have, I want to go to the next example. Another example which I want to mention is here. Thermal stress analysis of a reactor pressure vessel bolted closure. And this is the reactor vessel assembly, and this is a part of it. Okay, as the system is symmetric, we are modeling only a section, a portion of it. And here you can see the files. We have two kinds of files, heat transfer analysis and structural analysis, because they have used semi-thermo-mechanical analysis. I will talk about it in chapter 14, how to do a semi-coupled thermomechanical analysis. And here I want to use the Python file. In this example, we don't have any IMP file. We have only Python files, and I want to show you how to use them. Here I open this one, and here we have access to all of the parts. This is a CAE file like my CAE files in previous sessions. We have everything here. This is the assembly. This is the step. And here we have interactions, loads, and mesh. That's it. And you can check it, and also there are another files. How to purchase packages or individual chapters. Each of the packages and individual chapters includes CAE, JNL, and IMP files, step-by-step tutorials with detailed explanations and investigation of the results, slides and reference papers, and standards. Packages specifications and payment details are provided in the video description. Also, you can pay the cost of the packages in 2, 3, or 4 installments according to your budget or income. In the future, updates will be provided for free for everybody who purchases each chapter or each package. The cost of each chapter or package will increase after each update for new buyers, but those who purchase the package would have endless access to all the upcoming updates. This will make the content up to date for new needs and new problems which must be solved via FE simulation. You can contact us using Telegram or WhatsApp, or you can send email to us. We can have one-on-one tutoring on the AnyDesk WhatsApp, and we can make special tutorials to your order. We can conduct high-quality simulations for your thesis, exercises, and industrial projects. And we offer support in writing the modeling and result discussion part of your thesis. And we have consulting services for MSc PhD positions or job interviews, and we can help you to prepare the presentation of your simulation works. Now I want to suggest you several related videos of our YouTube channel. Thank you so much for watching this video. Have a good time. Goodbye.